All right, so we've got some homework to be going over here. Now this stuff will be on the test, so be aware of that. All right, so this is the first one. Now, what you want to do on this, if you want to find a moment, what you got to do here is work through the basic pieces of a moment. The basic pieces are the vector from the point to the force, which we call R, because R is how we call out position vectors. Oh, my pen has decided it doesn't want to work. The program's locked up. Come on now. Okay, so we're having some problems with my pen. So here we go. So this first one here, we have the angles that this vector makes with lines parallel to the x, y, and z axes. If this were 60 degrees in here, could I use that 60 to break that vector up into x and y components, even though it's not at the origin of my coordinate system? I think I could. Yeah, there's no laws of physics that I'm breaking there or anything. I think I'm pretty good. So I could do the same thing in 3D, okay? So where I'm going with this is, even though that force is not at the origin, I can still use those angles as given to break it into x, y, and z components, okay? So I can just go ahead and do that. And I'll take the 800 times the cosine of the three angles with the lines over there at C that are parallel to the x, y, and z axes. So I take 800, the magnitude, times the cosine of the three angles. Easy enough, okay? And that'll get me a force vector at C. So we okay with that? So the first there is to come up with a force vector. Okay. And that one's actually, you know, in the one we did in class, we used a position vector, which is good, but you don't, we have a different way of getting the force vector on this one, but that's no big problem. I mean, we just need to get a force vector however we do it. So there's the force vector. Now, what you need next is a vector that extends from A to C, okay? And that's the position vector.
What will happen if you go from C to A?
Okay, that's a good question. So what will happen if you go from C to A? What will happen is, now, in those dot product problems, I was mentioning that you could go either direction and it really wouldn't make a big difference. In the moment problems, it is a little bit of a difference, okay? So what would happen if you go from C to A is you'll get the negative of the answer you want, okay? So you want to be sure that you're going the proper direction from the point to the force. That's how these force vectors go, okay? So from the point about which you're taking moments to the force. So I think of a wrench being put on the point, the nut, and then going to the force, which is where your hand's going to push on it. So think of that. That's one way to remember it. But however you do it, remember it, because it's a pretty common error for people to make. And so, just be aware of that one, okay? You go from the point to the force. And direction does matter when you're doing moment vectors, okay? Okay, so we get a force vector. Now, what we're going to do is we're going to go from the point to the force. Now, remember that you're going to reverse the order of that. And that was something that I noticed on that homework I just handed back, was sometimes people were getting RAC, attempting to get it by taking RA minus RC. That's not correct. To get RAC, you have to take C minus A. You got to switch the letters when you do the subtraction. Okay, so I got coordinates on these points. notice that point C doesn't have any line, any dimension line in the x direction coming to it, so it has a 0 for x, okay? Sometimes that might throw people a bit, but if you have no line, you got no dimension, okay? So that's pretty straight up. Negative 0.7 in the y, 0.4 in the z. Point A here, we're going negative 1.1 in the x, 0.9 in the y, and 3.3 in the z, okay? So we'll subtract those, and that will get us a position vector, like so, okay? So you'll get positive 1.1, which is a positive x, a negative y of 1.6, and a negative z of 2.9. So that's the position vector. That's how you get from A to C. C is a point on the force. Okay. Then what you do is you cross them. You cross position vector first, force second. I have the formula there for doing a cross. It's right off your formula sheet. You could use that determinant method that I was showing you that I learned years ago. However the heck you want to do it is fine, but you execute the cross. Just realize you've got the formula for doing it on your formula sheet. Okay.
And if you do it backwards, it would be an answer.
If you do it backwards, right. If you do F cross R, you'll get a negative answer. So what happens if you use the position vector, in this case from C to A, and do the negative of the cross, F cross with R? You will get the numerically correct answer. But if I see that on the test, I'll mark you down twice for it, okay? So be aware of that. Do it in the proper way, okay?
So is that the general rule always? It's the R cross F?
Yeah, that is more than general rule. It is specifically the formula for finding a moment. So you always do it, invariably do it that way. It has to be R cross F. Okay. Okay, so position vector from the point to the force. When you do a position vector, to get the position vector AC, you take C minus A, you reverse the order of the letters. And then when you do a moment, you take R crossed with F. Okay. And that gets you the moment. So there you go. That's how that goes. All right. So we got any questions on that one? Doing all right? Okay. All right. Now that'll be on the test for sure, so get that one figured out, okay? I mean, and I didn't get that test review copied off. I'll get it to you tomorrow, but you know, you'll do a moment, you'll do a dot product, you'll do a force vector and all that. So just, you know, there's even a flow chart on page 325 if that's of any help to you. I don't know if it is or not, but get those processes figured out. You know, there's no way to throw you a curveball on that. I just tell you, find a moment, find a projection, and find a force vector. You know, so get that stuff figured out, okay? Yeah, question there?
Will the numbers on the test be numbers we can do in our head, or we need to
Yeah, you'll need a calculator, yeah. And a non-programmable calculator that you've used before so that you're not figuring it out in the middle of the test, which is I've had people do, and that's a bad idea, okay? All right. Cool. What do you got there? I mean, that's a 36.
Yeah, it's a 30.
30, yeah, 30 is okay.
Nothing I can do.
Oh, you can use a 30 and a 36. It's just not a programmable one. I mean, I'm not going to throw a matrix at you. It's just a time consuming. I don't want you to have to. I want you to spend your time on a test doing static stuff, calculation. I mean, you might have to do a matrix, you know, but you could do it by figuring out the equations similar to how we were doing the homework and such, okay? Yeah, that's just, okay. Oh, I see, okay. And you got to show your steps, too. Okay. All right. Are we good?
You have an intermediate check there, but you didn't use it.
What?
The intermediate check bottom right-hand corner of
Right.
that slide.
That was to get that force vector. I didn't. Keep jumping over the stupid thing. Yeah, okay, it's cosine 42, cosine 103.
Oh.
That's what that is. I just throw those in there sometimes. I guess I didn't use it directly, no. Okay. So that's that one. We're good on that? Questions? Good. All right. Okay, 211 follows from this one. So why don't we just do 211 next? Have a look at that. That's a moment about an axis. So what you do with that is, now, one other thing I want to mention on this moment. So the first question is, does the length of the moment arm affect the magnitude of the moment? Yes, it does, okay? The length of the moment arm affects the magnitude of the moment, right? The bigger, longer wrench you use, the more torque you get on the bolt, right? So, do you use a unit position vector when you do a cross, when you do a moment? No, you don't, because you don't want to take the length out of the position vector. You want to leave it in there. A unit vector is when you extract the length out and take it out and get rid of it, so you're left with a direction pointer for a unit vector. But in a moment, you want the length in there because it affects the magnitude of the moment. So do not use a unit vector in there for a force, for the position, okay? The R is not a unit vector, it's R, it's an actual position vector, okay? So remember that, okay? Now you use unit vectors when you do dot products. Search the web and windows, can I do that? Escape. Good. Okay. All right. So what we've done on 201 is we found the moment. It's negative 1333I minus 2278J plus 751K. If we want to find the moment about that axis there, what we would do is we would dot that with the unit vector for the axis. So now we're doing a dot product. You do use unit position vectors for dot products. Okay, so the problem here is to find the moment of the force about this axis, i.e. how hard will that force make that little thing on the bearing sitting there with the plate on it spin about that axis. That's really what that means. So if that force were projected back onto the axis, updates are available. Get updates. Don't seem to have too many options on this at the moment. There we go. I guess not. Yeah, I know. I'll do that. All right, thank you. That's probably good advice. All right. So now we want to think of that force doing that and being attached to that plate. And what that's going to do, of course, is that's going to take this little thing and spin it, or attempt to. And by finding the moment of this thing about the axis, we're going to find out what sort of moment is attempting to spin that plate on that shaft about those two bearings there, okay? That's the physical significance of what we're finding now, okay? So to do that, we're going to take the moment vector that we already have about A, and we're going to dot it with the unit vector for the axis, and that will tell us the moment of the force about the axis AB. So to accomplish that, you get the moment vector from problem 201, and you dot it with the unit vector for the axis. So once again, now this time you got to find a unit vector, so you just do the stuff for finding a unit vector. You to find RBA, I take RA minus RB. All right, and I just line them up right in one above the other so they're in nice columns. I could just do the subtractions. Take the square root of sum of the squares and I get the magnitude. It's 4.54. Divide that through the vector and I'll get a unit vector. Okay. Then I'll just do a dot product. And that's basically the drill on this. Okay. So I need UBA. I take RA minus RB. I get RBA. Find the magnitude of it, which is 4.54. Divide through, and I get UBA. That's what I'm doing there. And what I will do next is dot it with the moment vector. That's how you find the projection of a moment, in this case, onto the axis. Remember, what a moment vector represents is the axis about which the moment would occur. So in problem 201, we found the moment vector about A, which is kind of what I call a free moment. If that force could cause a spin about A in any direction it wanted, so to speak, we have the moment vector for that. But now we're going to essentially force that moment to occur about that axis AB. So we're going to project it down. Okay? Take the moment vector, project it down to the axis. That's what we're going to do. All right. So the first step in doing that is finding a unit vector for the axis, UBA. And that's found like any old unit vector. Just go through the steps. Okay. And you know, if you're studying for this test, maybe get kind of whatever cards or something that got these sequences laid out on them. Get them figured out. Get them in your memory. Okay. You know, because you don't want to be scratching your head during the test on this stuff. You want to know the steps. Bang, 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 bang. I'm just flat telling you, you know, you're going to get this stuff. So just prepare yourself for it, okay? All right. So that's how you make a unit vector. Subtract the vectors in the reverse order that is designated. Find the magnitude with theorem of Pythagoras. Divide through, you get a unit vector, okay? Once you got the unit vector, you dot it with the moment vector, or multiply the like components together and add up the results. Okay, so those are not I, J, and K components. Those are just numbers that you're adding up to get the moment magnitude, is what they are. So you just multiply the like components together, add up the products, and you'll get the magnitude of the moment. You can multiply that by the unit vector if you want it in a vector form. Okay, we doing all right with that? So we're good? Good to go. Okay. All right, so what we did there, we looked at the moment that force would cause about A initially. And what we got out of that was negative I, negative J, and was it a positive K? Yeah, I guess it was. So negative I, I'm going to attempt to sketch this using just the mouse. Well, I'm underwater in padlock chains, so we'll see if we can do all this. So negative I, negative J, and positive K. Okay, something like that. So that initial moment vector was something on the order of this. Of course, that color was not the one I wanted. Darn it. This might not have been my most brilliant idea, but we'll try it again. Okay, so negative I, so that we're going to start at A, because that's what their moment's about. We're going to go in the negative I, negative J. How did they compare the proportions? Okay, the J is bigger. So the negative J was like that, and then a little bit of a positive K, right? So the vector itself, if we were to draw it in there, would look something like that. then what we did was we projected it down. Okay, so what that is, that vector there is MA. That vector represents an axle to the wheel that would be caused by that force spinning about the point A, right? So what we're going to do next is we're going to force that spin to occur about a different axle, about AB. So what we're going to do with that vector is we're going to project it down onto AB by using a dot product. So we're going to just pull that thing down. That's a right angle. And what we got was this vector here along axis AB that represents that spin about AB. So the vector we got looks like that, and it's tough to draw, but there we go. It's directed along AB now, and it's kind of coming over like that. That's what it's doing. That way my thumb points this direction, which means my sketch is off. Anyway, okay, so that's what we're doing there. We're projecting the moment vector onto axis AB. Okay, now 202, you need to, let's get good. Okay, so for 202, what we want to do is we want to first get the force vector. So you don't have any answers at all to this one, right?
It gives us the...
Just the final answer?
Yeah.
Is that pretty much it? Okay. Selection, page, document, tool. Oops. Pen, text. Oh, man, this could be exciting. But anyway, here we go. So what we're going to do is we'll get you some intermediate answers to this one. Now, I want you to do this one twice. Once using the position vector from A to B, and the other time using the position vector from B to C. All right, so what you're going to do is the same process that I just outlined. And you're going to find the force vector first. And then you're going to find a position vector from the point about which we're taking moments, which is point A to B, and then from A to C. And then once you've got those, you'll just do the cross product. So that's the process on this. So what we're going to do first is get our, what's BC? And what that is, and I can't use my pen, so I'm having to type. So that's the vector from B to C. Okay, so I'll get you some intermediates on this. Did I bold that at all? Not really. Yeah. Okay, so RBC, and I'm just going to write down the numbers here, is equal to -7,311. Okay. The magnitude of RBC, when you run those numbers, you should get 13.38. Let me do that. I'm only moving. I'm not going to be able to do this. Maybe. That's good. Okay. And then FBC. What that's going to equal is -241, 103, 378. Okay. So you go through the process of finding the force that goes from B to C. Okay, once you've got that, what you want to do then is find position vectors that you can cross to find the moment. And you could use the position vector from A to B and also from A to C. So I'd like you to do it both ways just to get some practice at it, okay? So you could use R from A to B. And why don't I just call that capital R, just so it's apparent what I'm trying to do here. So I'll just do that. Even though you don't use capital R's for position vectors, I'll go ahead and do that just to, so we can kind of tell what the heck I'm doing here. Okay, so what RAB is equal to is 2 minus 9 minus 3. Okay. And then when you do the cross, and then what you'll do is you'll go M, the moment about, we're doing moments about A, is equal to R, and I just did, was it AB that I did? Yeah, RAB crossed with F BC. Okay. And that's equal to, as shown in the solution, negative 3095, negative 34.5, and negative 1960. Keeping in mind that you could have rounding differences, especially on that middle term because it's so small. You might have a fair amount of rounding error on that. No worries, okay? All right, and then we could also use RAC for that. And that would be negative 5, negative 6, 8. And then, once again, we get MA is equal to RAC crossed with FBC. And that should get you something close to the same MA, although you might have some rounding errors there. No worries there, okay? Okay, so those are the steps for finding a moment about A. Find the force vector BC, cross it with the position vector from A to B or A to C. Okay. All right. So just be sure that you, that you know those steps and can apply them. All right. Now let's say you're taking one of my tests and you know those are the steps, but you can't remember if it's RAB or RBA. What you do is you guess. You go ahead and do the rest of the steps, right? Because when I grade, I give points for each of the steps. Don't just stop dead in the water. If something holds you up, make an assumption, keep going, because I'll give you a certain amount of points for doing the cross product. So if you know how to do a cross, but you can't remember one of the things that goes into it, just guess and show me that you know how to do a cross, okay? I mean, there is skills for taking tests, right? And that's one of them with me. Everybody grades different, but, I kind of make a little chart and I say, okay, I'll give so many points for this, so many points for that. So don't lose points down here just because you got stumbled on a step up there. Keep rolling. Show me you know what to do, okay? It's the other little trick on tests. If you need to remember something, you got short-term memory and long-term memory, right? Just keep repeating it in your mind. For short-term memory, get your test and just slap it right on the top. Bang, it's there. I mean, these are kind of unrealistic skills for working environment, but what the heck, man? I mean, learn how to take tests. Do well. I mean, if there's certain things you can't, you want to remember, put them in your short-term memory, but you got to keep them active or they'll leak out, okay? So keep repeating them. And as soon as you get your test, just slap them on the top. I mean, that's fair. It's following the rules, okay? I don't know if there's other tricks. That's what comes to mind right now for these tests. Okay, so we got any questions on this one? And, like I'm saying, this stuff isn't like, it is tricky, I know, but it's not, it's not like, it just is what it is, right? Find a moment, take the force, cross it with the, or take the position vector, cross it with the force. That's what you do, okay? You just need to kind of figure this stuff out, okay? Okay, we got one more. Yikes. Okay, the last one will not be on the test, but it's another thing to be doing, so it's the last little bit of homework. It does relate to moments, though it's a different type of moment than what we're doing here. So this stuff will be on the test. This very last one will not. All right, so we'll open this thing up. Where are we? Is this it? I bet it is. Press escape to cancel. Tap to add title. There. Okay, the last one regards couples here. So we have this hole saw. We went over hole saws a little bit and what they look like and all that. Is this actually going to work? Maybe not. Yeah, might. Okay. Okay, so we have a door manufacturing company. They have this double hole saw jig, and we have two hole saws, A and B, spinning in the opposite directions and applying those couples. Let's find the forces on the supports at C and D that are created by the couples. We got any questions on that one? Doesn't really sound that way. Okay, we got a question here.
Summing the torques.
Couples are additive. Yeah, you can add them up. Certainly, yeah. Any type of moment can be added to any other kind of moment, so they're additive. Might just kind of let you kind of work on this, amongst yourselves on this. I'm thinking less, but if there's questions, I'll certainly take them.
Do you have the final answer? I got 14.
I couldn't solve this one. It was too hard for me. I gave up. These manufacturing companies send me problems and I can't figure them out, so I just give them to you guys. Figure you'll get them. I start talking to each other. Yeah, I mean, we get a little bit more in OSU mode here. Just figure it out. And it's always good to have smart friends, but to have smart friends, you got to help them too. Everyone has to contribute. That's kind of how that works. And let me just mention that there's nothing. This can be done in 2 or 3 lines of math. There's no real tricky calculations on this whatsoever. It's very straightforward. Sometimes people will work at this a little bit to figure it out, but the calculations are nothing on this. They're quite simple. It's more the concept. And also, I don't want to just tell you how to do it because you won't learn then. I'd just like you to think about this one. It's pretty straight up, really, once you get it. It's very straight up, actually. Okay. All right. So this stuff's due tomorrow. Doing okay? Okay, I'll get you a test review tomorrow, too. Okay, we'll go over that a little bit. It's also online, for those of you online, it's in the downloads. Okay. All right. Okay. All good.